Today we are going to be solving three variable systems, but this time by a matrix. This is our last method to solve systems by hand. Solves three variable systems with a matrix. So first of all, a matrix, that's a vocabulary word you're going to want to know. Matrix is what we call an array of numbers used to represent equations just without the variables. Basically, all we're using in a matrix is the coefficients of the variables, and that's it. So here's a quick example. So if I have a system such as 3x plus 2y equals 5, and let's say negative 2x plus y equals negative 10, we can translate this into a matrix that uses just the coefficients of our variables. So a matrix is shown by having a bracket over the entire numbers, and we're going to put the top equation in the first row. So we're going to have a 3 for the x, leave a space, 2 for the y, leave a space, and put the 5 on the equal sign. And then on the second equation, we're going to do the same thing for the second row. Negative 2, 1, and negative 10. Now, a couple things about this. If you notice, everything lines up. This column here are all of your x's. This column here are all of your y's. And this column here are the equals. That's what the equations are equal to. So we kind of use a dotted line as our equal to in a matrix. So real quick, remember columns are up and down. Think of like the Greek columns. And then rows are side to side. Okay, columns are up and down, rows are side to side. Let's talk about how to set up a matrix. Let's talk about how did I know how to do that. So setting up a matrix. Here's our first little section. How do we set up a matrix? So here's our first example. All I want to do is I want to translate this system of equations into a matrix. So 4x minus 4y plus 4z equals negative 4. 4x plus y minus 2z equals 5. And negative 3x minus 4y minus 4z equaling 16. So we're going to write this in its matrix form. So I'm going to need 3 rows. So I'm going to use 3 lines. I'm going to need 3 rows. And I'm going to need 4 columns. I'm going to need a column for the x, a column for the y, column for the z, and then a column for the number to the right of the equal sign. So let's write our first equation. So we're going to have 4 in the x's, space, negative 4 for the y's, space, 4 for the z's, space, and a negative 4 to the right of that little equal sign dashed line. And then we have equation 2. The x is a 4, the y is a 1, z has a negative 2 in the front, and the equal sign is a 5. And then the last one we have negative 3, negative 4, and negative 16. And there's your matrix. Now, here in a minute, we're actually going to solve with this matrix, but this is how you set up just a basic, how do I translate from a matrix or from an equations to matrices. Let's look at another example. Let's try example 2. So we're going to translate this into a matrix. That's all we're doing right now. So 5x plus 8y equals 25. Then we have negative 2x equals negative 3z plus 16. 17y minus 5x plus 8z equals 22. Now you may already notice some differences between example 1 and example 2. For instance, if we look at this first equation here, I have an x and a y, but no z's. So I'm going to change this guy, and I want to write the equation, but I want to put a plus 0z as a placeholder, because even though there's not any z's, we still need to put this into our matrix as a 0. So we need to add any variables that we're missing. For the second equation, you may notice that my x's and z's are not on the same side, and we're missing a y. you need to have this in standard form. So standard form is ax plus by plus cz equaling d. A, B, C, and D are all just numbers. So this is what standard form looks like. You've got all your x's, y's, and z's on one side, and your plain numbers, your constants on the other. So that means I'm going to have to add 3z to both sides. So what's going to happen is you're going to have negative 2x plus 0y because I don't have any y's, and then you're going to have plus 3z at the end. Make sure they're in the same order. That's the issue with the third equation. We have y first, and then x, and then z. So we need to rewrite this guy to put our x first, then our y, then our z, and then the number at the end. Because remember, your columns all have to be the same variable. You can't have x's and y's mixed in your columns. So now that we have everything in the right place, pause the video and try to write your matrix. This is what you should end up with. You should have 5, 8, 0, and then 25 on the right side of that dashed line. Negative 2, 0, 3, 16. Negative 5, 17, 8, and 22. All of your x's are in this column, all of your y's are in the second column, and all of your z's are in the third. Now, you may want to start a new page for our first solving example. So this is our next section. How do we actually solve using a matrix? Now that I know what a matrix is, how do we use it? Okay, so here's what we want to do. We basically need to get our matrix, into something that we call row echelon, E-C-H-E-L-O-N. Don't really worry about what that word means right now. Row echelon form. That's just the form that we call it. And you'll need that when you go to our calculator here in a couple of days or so. This is what row echelon form looks like. Usually we have 3 equations, so I need 3 rows. The first row is all numbers. So you've got your x, your y, your z, and then the number to the right. The second row has a 0, some number, and then the number to the right of the equal sign. Your third equation has 2 zeros, a number, and then a number to the right of the equal sign. So remember, these are our x's, these would be our y's, and these would be our z's. So let's think about what this means. This last equation here means I have no x's, no y's, and I've got some kind of z equaling some number. That means this isn't only a single variable. Then the second equation has a 0x, I have some y's, some z's, and equaling to a number. So this is in 2 variables. So I've got 1 variable, 2 variables. And this top equation has no zeros, so this is all numbers here, which means this is in 3 variables. So I've got 1 variable, 2 variables, and 3 variables. That'll come in handy soon. Now, how do we get them to look like that? Well, we have some rules. We use row operations. We call them row operations. There's 3 things we can do. The first thing we can do is we can either add or subtract 2 rows together. Notice we're doing rows, not columns. The second thing we can do is we can multiply a row by a number other than 0. I can't multiply by 0. So I can multiply by a 2 or a half or a fifth or a -7, whatever. And then the last thing we can do is we can swap the order. So I can swap the order of 2 rows. We don't use that one very often. But those are the 3 things that I'm allowed to do with a matrix. Those are called row operations. So using these row operations, we are going to get our matrix to look like this, and then use what we call backward substitution to find the rest of our variables. So let's do an example. So this is technically example 3, so let's look at this guy. All right, so we want to solve Here's our system, 1, 2, 3 lines, because I have one equation on each line. Negative x minus 5y minus 5z equals 2. 4x minus 5y plus 4z equals 19. And we have x plus 5y minus z equals negative 20. So we're going to solve this with a matrix. So first, we need to make sure we can actually write this into a matrix and that we have everything we need. And we do. So if we look at our equations, I've got standard form, standard form, standard form. So we're good to go. So let's write our matrix. So our first equation is negative 1, negative 5, negative 5, 2. And this is where that little dashed line is. You've got 4, negative 5, 4, 19, and 1, 5, negative 1, negative 20. So there's our beginning matrix. Okay, let's do some labeling. I'm going to call this top equation row 1, R1, the second one, R2, and the third one, R3. This is going to be useful to help us keep track of what we are doing. So now we need to make our zeros. So let's look back at what we had. This is our goal. So I need zeros in this little bottom left-hand corner. That's where I need my zeros. So we're going to start with the bottom left corner first. Let's try to get that to be a 0 first. So we're going to make this 1 into a 0 somehow by using those 3 row operations. So the first thing we're allowed to do is add or subtract 2 rows together. And I see that in row 1, if I need this spot to be a 0, I need to add a negative 1 to it. Well, there's a negative 1 right here. So in order to make that 1 a 0, I'm going to have to take row 1 and add it to row 3. And that'll give me a new row 3. So here's what we get. If we add row 1 and row 3, so we're going to add negative 1 and 1, and we're going to get 0. Then we're going to add negative 5 and 5, and we're also going to get 0. Look at that. I actually got 2 zeros for the price of 1. And then we're going to do negative 5 plus negative 1, which will give us a negative 6. And then you also have to add the equal signs too. So 2 plus negative 20, which equals negative 18. Now, the other 2 equations, the other 2 rows don't change. We didn't mess with those. So let's rewrite them. Negative 1, negative 5, 2, 4, negative 5, 4, 19. So now the next place we need a 0 is this 4 right here. I need to make that into a 0. So I would need to add a negative 4 to it, but all I see is a negative 1. So let's try to change. So let's see what else I can do. I can also, according to this property too, I can multiply a row by a number other than 0. So I need a negative 4 in this spot right above my red 4. So I'm going to multiply by 4 to the first row to give me that negative 4 that I need. So let's go all the way back down here. So we've got, when you multiply by a 4, 4 times negative 1 makes negative 4, 4 times negative 5 makes negative 20, 4 times negative 5 makes negative 20, and 4 times 2 makes 8. And the other 2 equations are not changing. 4, negative 5, 4, 19, and then we still have 0, 0, negative 6, negative 18. Here's our little equal sign and our matrix. Now, we do still need this to be a 0. But now that I have a negative 4 above it, I can use row 1 and add that to row 2 in order to get a 0 in the spot that I need. So if we have negative 4 plus 4, we get 0. Negative 20 plus a negative 5 makes negative 15. Negative 20 plus 4 makes negative 16. Negative 20 plus negative 5 makes negative 25. Negative 20 plus 4 makes negative 16. And 8 plus 19 makes 27. And then the other 2 equations aren't changing. We have 4, negative 20, and 8, 0, 0, negative 6, negative 18. So now that we have zeros in that L shape down in the bottom left corner, we can go ahead and put back our variables. So we can put our variables back in here. So this first row is the first equation. We have 4x minus 20y minus 20z equaling 8. Then we have that blue one. There's 0 x's, so I don't need to even put an x at all. I'm going to start at the next one. Negative 25y minus 16z equals 27. And then the final equation has no x's, no y's, but it does have negative 6 times z equals negative 18. Now this is where you use backward substitution to find your variables, because I can solve this equation very quickly. Divide out the negative 6 and we get z equals a positive 3. Okay, now look at the blue equation. The blue equation has a y and a z, so I can substitute the z value that I just found. Negative 25y minus 16 times z is a 3 equals 27. And we're going to solve this guy for y. Negative 25y, negative 16 times 3 is negative 48 equals 27. So we're going to add the 48 to both sides. We get negative 25y equals 75. And divide by negative 25 to find y. So we end up with y equals negative 3. Now we have 2 out of 3 variables. The third one, look at the top equation. We have x's, y's, and z's. So I can use that to solve for my final variable. 4x minus 20 times y was negative 3 minus 20 times z, which was positive 3, equals 8. So we have 4x, negative 20 times negative 3 is a positive 60. Negative 20 times positive 3 is negative 60, equals 8. Well, 60 and negative 60 add to 0. So all we have is 4x equaling 8. Divide out the 4, and we get x is equal to 2. So our final solution is 2, negative 3, 3. Solving the matrix portion is just a giant puzzle. Let's look at one more example. Again, you may need to start on another page, and that is perfectly fine. So example 4. And I want to do a couple different things with this one. So we're going to solve this matrix. X minus y plus z equals 2. 2x minus 3y plus 5z equaling negative 3. And we have negative x plus 6y plus z equaling negative 1. So again, this one is ready to set up in our matrix. So I'm going to do that below because everything's in standard form. So we have 1, negative 1, 1, 2, 2, negative 3, 5, negative 3, negative 1, 6, 1, negative 1. And this is our little equal sign. Okay, this is row 1, this is row 2, and this is row 3. So before I did everything separately. I did the multiply and the adding separately. I'm going to kind of show you some shortcuts here. So I need to make this negative 1 into a 0 first. So I know that I have to add a negative 1 to a positive 1 to make a 0. And I do have a positive 1 here on row 1. So we're going to take row 1 and we're going to add it to row 3 to create our new row 3. So if I do 1 plus a negative 1, I get 0. Negative 1 plus 6, we get 5. 1 plus 1, we get 2. And 2 plus a negative 1, we get a 1. And then the other equations aren't changing, so we're going to rewrite them. 2, negative 3, 5, negative 3, 1, negative 1, 1, 2. Woo, that was a curly one. Okay, now I need a 0 here. So to get a 0 in the 2 spot, I need to have a negative 2. Well, all I can use is this guy right above because I can't use the 0 because 2 plus 0 is never going to give me it's not going to ever cancel out. So I need to use the one above it. So I also need this to be a negative 2. So the only way I can do that is by multiplying negative 2 to row 1 and then adding to row 2. So we can do two things at once here. I can multiply and add at the same time. So let's see. So if I do negative 2 times 1, I get a negative 2. Plus the 2 that's already there, I get 0. Oops, let me change it to green. Okay, Now if I do -2 times a -1, I get a 2. So I'm going to erase that. So now we get a 2, and 2 plus a -3, well, that's -1. That's our next one. Okay, now we need -2 times 1, which makes -2, plus 5 makes a +3. Last one, -2 times 2 makes -4, plus the -3, we get -7. So you can do multiply and add at the same time. If it's easier for you to do them separately, then do them separately. And then the red one doesn't change either. 0, 5, 2, and 1. Okay, so now the last place that we need a 0 is here. Now, since I have 0 and 0, I have to make sure I don't lose a 0. So for example, I can't add this row to the first one because 0 plus 1 makes 1. I lose my 0. So we're stuck to only using these two. So that's okay though, because I see that there's a -1 here. So I know that I can do, I'm going to come down. I'm going to go ahead and draw my arrow here, showing where the workflow is going. Okay, I know that I can take row 2, and if I multiply that by 5, I'm going to have the correct 5 to get rid of this 5 in the red. So I'm going to have to do 5 times row 2 and then add it to row 3 to give me my new row 3. So let's see. 5 times 0 is 0, and 0 plus 0 makes 0. 5 times -1 makes -5, plus a 5 makes 0. 5 times 3 is 15. 15 plus 2 makes 17. And then 5 times -7 is -35, plus 1 makes -34. And then the other two equations are not changing. We still have 0, -1, 3, -7, and 1, -1, 1, 2. Now our matrix is done. Since I have my zeros in the left corner, I can go ahead and put back my variables. So this first equation is really x minus y plus z equals 2. The second equation has 0 x's, so we have -y plus 3z equals -7. And the third equation has no x's, no y's, but we have 17z equaling -34. So we're going to use this to solve for z. So we're going to get z alone first. So 17z equals -34. Simply divide by 17, and we end up with z equals -2. Then we're going to use our second equation, our green equation, -y plus 3 times z, which is -2, equals -7, and we're going to solve this for y. 3 times -2 is -6. Add over the 6. -y equals a -1. Divide out the -1, and we have y equals 1. And then lastly, we're going to use the top equation to find the x. So x minus y is a 1, z is a -2, equaling 2. So these I can go ahead and add together. So we have x minus 3 equals 2. Add over the 3. And we get x is equal to 5. So your final solution here is 5, 1, -2. For the final example, I want you guys to try this example on your own, but I will help you start it. Example 5, we're going to solve this system here. So we have x minus y plus 2z equaling 3. Y minus 3z equals 2x minus 4. And we have 4x plus z minus 3y equals -8. So normally we can just go and put this right into the matrix. But our problem is not everything is in standard form. So remember, standard form is ax plus by plus CZ equals D. All your variables on the left, your constants on the right. This first equation is fine. He's good to go. So we have x minus y plus 2z equals 3. The second equation, however, we need to move this x. So we're going to have to subtract 2x from both sides. And the x's go in the front. So negative 2x, then plus y, minus 3z equaling negative 4. And the third equation is just out of order. We need to flip these two and make it in the correct order. So 4x minus 3y plus z equaling negative 8. So with this one, now you are set up and ready to put your system into a matrix. So solve this guy down, and you should end up with the solution of negative 2, 1, 3.